Hi everyone, this video is going to be over the sum and difference identities. So the sum is when we are adding two numbers together, and a difference is when we are subtracting two numbers. So the goal of this is to break down whatever angle we're given into an angle that we know. Because sometimes we need to find angles of things that we don't know yet. Or that we don't know how to do unless we break it down into one of the special trig values that we know. So we have some sum identities, we have some difference identities. Each one has a sine, cosine, and tangent. You do need to be careful because some of these identities are very similar and you don't want to accidentally use the wrong angle. So here we go. In example 1, we want to use the sum identity to find the value of sine of 285. So that tells me that I am using the sum for sine. So sum for sine is this one right here. So all I'm going to do is I am going to rewrite that formula right there. So we get sine of a plus b equals sine of a times cosine of b plus cosine of a times sine of b. What we need to do is we need to figure out two angles that we know their trig values to that add to give us 285. Because 285 is not one of the trig values that we are expected to know. So we break it down into the things we know. How I end up doing it is I usually work backwards and I figure out, okay, 285 minus an angle will give me another angle. And if I add those two, then it should give me the 285. So if I try this and I just try 30, when I subtract 30 from it, I get 255. Well, we know how to find 30, but 255 is not an angle we know. So this one is not going to work for us. So we move on to the next angle. We can try 45 degrees. When I subtract 45 from there, I get 240. 240 is an angle we know, so we could use this and we could use this. Okay? If you did not know that you know 240, you could have moved on and tried 60. And when we subtract 60, we get 225. So what you need to decide is which one do you know better? Do you know 240 or do you know 225? Either way we go, it does not matter. You will get the same exact answer. So for the purpose of the video, I will use this last one, but again, you will get the same results with the 45 if you decide to use it. So here we go. Now I didn't break this down, so let me go back a second. What I'm going to do is I'm going to let 60 degrees be the A value and 225 be the B value. And so anywhere there's an A, I'm replacing it with 60. Anywhere there's a B, I'm replacing it with 225. So that's all I'm doing right here is replacing. Okay, now we're going to start simplifying. So this is where the trick comes in. So sine of 60 degrees, that would be your index finger. Your index finger goes down. Sine is the bottom 3 fingers. So that tells us that we get the square root of 3 over 2. Now, cosine is not one of our main first quadrant angles, so we need to find the reference angle to that. 225 is in the third quadrant, so we're going to subtract 180 from it. When we subtract 180 from it, we get 45 degrees. So cosine and sine of 225 have a reference angle of 45 degrees. So in the third quadrant, both cosine and sine are negative. So whatever value we get, we just need to make sure that we make it negative. So cosine of 45 degrees is the middle finger. Cosine's on top. I have 2 fingers. That means rad 2 over 2. And because it's in the third quadrant, it's a negative rad 2 over 2. Then we are going to add the product of cosine 60 and sine of 225. Cosine of 60 means, again, I put down my index finger. I have 1 finger left on top, so that would be the square root of 1 over 2, which is just 1/2. Sine of 225 goes back to that reference angle of 45 degrees. I put my middle finger down. I have 2 fingers left on bottom. That means it's rad 2 over 2. But since it's in the third quadrant, it is a negative rad 2 over 2. So now what we're going to do is we're going to multiply the fractions. When we multiply fractions, we multiply the numerators together, then we multiply the denominators together. So when we do this, the square root of 3 times the negative square root of 2 is equivalent to the negative square root of 6. When you multiply radicals together, you can multiply the numbers underneath together. So the square root of 3 times the square root of 2 becomes the square root of 3 times 2, which is 6. We multiply their denominators together, 2 times 2, and we get 4. Now, I am going to add the product of 1/2 times a negative rad 2 over 2. Well, 1 times a negative rad 2 is a negative rad 2, and 2 times 2 is 4. Now I see that I have 2 fractions that are being added, and they have a common denominator. So I can combine it as one big fraction over the same denominator. When you add or subtract fractions, you just add the top or subtract the top, and the bottom stays the same. So when we do this, we get a negative square root of 6 minus the square root of 2. And that would be our final answer in this question. So what can we do to check our work? Well, that's where we go to the calculator. And this is to check your work. We're going to add a new calculator screen. We make sure our calculator is in degree mode. And we do sine of the original angle, which was 285. And we get a decimal. Then I'm going to type in the answer that we got. So that was the fraction button, the negative square root of 6 minus the square root of 2 all over 4. I press enter. I see that the angles are the same, or sorry, the answers are the same. So that means we did our math correctly. This is only to check your answers. Decimals will not be accepted as answers on the assignment. So now that's it for example 1. Take a second to look over it. If you need to pause the video, pause it, write down any questions you may have, and then ask the next time you are in class. Moving on to example number 2, we want to use the difference identity to find the value of cosine of 225. Well, the cosine difference identity is this identity right here. So I'm going to start by copying that identity down. So we get cosine of A minus B is equal to cosine of A times cosine of B minus sine of A, sorry, it's plus sine of A, times sine of B. So now we need to think about two angles that we can subtract in order to get 285. So we can use the same process as that we did before. But instead of subtracting, this time I'm going to add to work backwards. So we get 285, and I am going to add an angle, which is going to give me a different angle, which is going to show me what two angles I can subtract to get 285. So if I am subtracting some angles or adding some angles, let's see. Let's just add 30 degrees. If I add 30 to 285, that gives me 315. I should know 315, and I know 30 degrees. So this looks like it works out for us. Check mark. So those are the two angles I'm going to use. Okay, you can double check that. Does 315 minus 30 give me 285? 315 minus 30 gives me 285, which is what I want. So that works out. Because this is a difference identity, that means that our bigger angle needs to be A, because that is how we get 285. If I let my smaller angle be A, it's going to give me a negative 285, which is not the angle we are finding. So that would be improper math. So bigger angle is A for the difference identity. So here we go. We have cosine of 315 minus 30 is equal to cosine of 315 times cosine of 30 plus sine of 315 times sine of 30. So we move and we start simplifying. Okay, 315 is not one of our main angles, so we need to refer it back to the first quadrant. So 315 is currently in the fourth quadrant. In the fourth quadrant, to find the reference angle, we do 360 minus 315. When I subtract those two, I get 45 degrees. So my reference angle is 45 degrees. Also, in the fourth quadrant, cosine is going to be positive, where sine is going to be negative. So just to help us out there. So cosine of 315 is similar to cosine of 45. So my middle finger goes down, cosine's on top. I get rad 2 over rad 2. I'm sorry, rad 2 over 2. And since it's positive, I keep it positive. Then cosine of 30, I put down my ring finger. 30 for cosine is on top, so that would be rad 3 over 2. Then I move on to the sines. So sine of 315 is similar to sine of 45 degrees. So I put my middle finger down. Sine of 45 degrees is rad 2 over 2. And this one is going to be negative because it is in the fourth quadrant. Lastly, I do sine of 30. So my ring finger goes back down. Sine is on bottom. So I'm multiplying it by 1/2. Now I work on getting a multiplying. So I multiply the tops together. The square root of 2 times the square root of 3 is the square root of 6. 2 times 2 is 4. I am going to have the negative square root of 2 times 1, which is a negative square root of 2. And then 2 times 2 is 4. Now that I have that with common denominators, I can write it as one big fraction over 4. And I get the square root of 6 minus the square root of 2. This right here is what cosine of 285 is, using the difference formula. So looking at this, we're going to check our answer. So cosine of 285 is this right here. So I'm going to type in the answer that we got, which is the square root of 6 minus the square root of 2 all over 4. And we get the same decimal, which means we did it correctly. Moving on to the last example. Before I do that, again, look over this, pause the video, reflect, see if you have any questions. If so, write it down and ask the next time you're in class. But we're moving on to example number 3, where we're going to use a sum identity to find the value of tangent. So a sum identity to find the value of tangent of 255. So that means we are using this formula right here. So I'm going to copy that down. So that is tan of a plus b is equal to tan of a plus tan of b, all divided by 1 minus tan a times tan b. So again, we need to find two angles that can add to give me 225. So off to the side, I just do a quick, let's see, 255 minus 30. That gives me 225. So we can use that if we want to, because we should know both of those. If we think about 255 minus 45, 255 minus 45, that gives us 210. We could use that pair as well. And if we check 60 we could not use. If we tried 90 we could not use, so it's probably just these two right here. So again, you get to decide which ones you want to use. For the sake of the video, I'm just going to stick with the first one that I picked or came up with. Again, the other one will get us the exact same answer, I promise. Now, what we're going to start with is plugging this in. So when I plug this in, I get tangent of 30 plus 225. So that is tangent of 30 plus tangent of 225 all over 1 minus tan of 30 times tan of 225. So let me go ahead and scoot that over so it looks a little more balanced. Boom. Okay. So now we start the trig part and then we go into the simplifying part. So tangent of 30 means that I put down my ring finger. Tangent is square root of the bottom divided by the square root of the top. Square root of the bottom is 1. The square root of 1 is 1. The square root of the top is the square root of 3, or rad 3. So for tangent of 30, we get 1 over rad 3. Then we are going to add tangent of 225. In example 1, we used 225. 225 was in the second quadrant, and we said it had a reference angle. Sorry, it's in the third quadrant, and it had a reference angle of 45 degrees. So that is my middle finger. For tangent, we do the square root of the bottom, so the square root of 2, over the square root of the top, which is also the square root of 2. So the square root of 2 over the square root of 2 is just 1. And because it's in the third quadrant, tangent is actually positive in the third quadrant. The nice thing about tangent is that because we already did the top, we know the bottom is going to be 1 minus 1 over rad 3 times 1. So Now we start the algebra where it's simplifying. So I'm going to take you to the part where I'm going to allow you to stop, and then I'm going to show you the completely simplified answer to this problem. And I did not show that part in class. So here we go. I want to be able to add the fractions, and I want a common denominator. So what we're going to do is first, we're going to start by rationalizing 1 over rad 3, meaning we want that radical out of the denominator. So we are going to multiply it by rad 3 on top and on bottom. When I do that, I get the square root of 3 over 3. Then, in order to add 1 to it, I need a common denominator. So I'm actually going to turn 1 into a fraction. And to get a common denominator, I'm going to multiply the bottom and the top by 3, which gives me 3 over 3. This step will allow me to add fractions. Now, I'm going to do the same thing on bottom. Luckily enough, we already did this part, so we don't have to redo it. But what I do want to tell you is that this right here, let me change my highlighter. This right here, when I multiply together, is just 1 over rad 3. So that changes this problem into 3 over 3 minus rad 3 over 3. So since my fractions now have like denominators, I am able to add them together. So when I add them together, I get one big denominator. So I have a fraction on top, that is rad 3 plus 3 over 3. And I have a fraction on bottom, that is 3 minus rad 3 over 3. When we have a fraction divided by a fraction, so this is my top fraction, this is my bottom fraction, we can keep, change, flip to do the division. So we're going to keep rad 3 plus 3 over 3 the same. We are going to change from division into multiplication, and we are going to flip the second fraction to be 3 over 3 minus rad 3. Now, when I do my multiplication to simplify, I see that a 3 on top cancels a 3 on bottom. So that leaves me with rad 3 plus 3 over 3 minus rad 3 as an answer that I will allow you to leave it in. But that is not the final answer. That is not fully simplified because we still have a radical in the denominator. So I am going to show you how you keep solving this to get the radical out of the denominator. Okay, but that right there would be where I allow you to stop. This next part is me showing you that you can keep simplifying this some more. So I am going to duplicate it right there. And I'm going to take off the highlighting part. So to keep simplifying this, again, in pre-calc, we do not like that the rad 3 is in the denominator. So what we're going to do, which is something you should have learned in Algebra 2, but maybe you didn't, which is okay. We are going to multiply by the conjugate. The conjugate is when we take the denominator, okay, and instead of saying 3 minus the square root of 3, we are going to do 3 plus the square root of 3. So we are multiplying by the conjugate of the denominator. How you get the conjugate is you change the sign of the radical. And so since I'm multiplying that on top, I'm also going to multiply that on, since I'm multiplying it on the bottom, I got to multiply it by the top as well. So what this turns out to be is 1 or 2 different FOIL problems. So the FOIL problem is rad 3 times 3, which equals 3 rad 3. 1 is under a radical, 1 is not. So you can just put them together and that's it. You cannot multiply what's underneath. Then I have rad 3 times 3. Rad 3 times 3, we know, is 3. I move on to my next one, which is 3 times 3. That gives me a 9. And then 3 times rad 3 is rad 3, plus 3 rad 3. So that is just the top. Now we move on to the bottom with the same FOIL. 3 times 3 is 9. 3 times rad 3 is plus 3 rad 3. Negative rad 3 times 3 is negative 3 rad 3. And negative rad 3 times rad 3 is a negative 3. So here we start simplifying and combining like terms. So that would be the these right here turn into a 12. Oops. This and this turn into a plus 6 rad 3. On bottom, we see that these cancel out, and 9 minus 3 is 6. Now, I hope you see that 12, 6, and 6 can all be simplified. 12 divided by 6 is 2. 6 rad 3 divided by 6 is just plus rad 3. This right here is the most correct answer, the most exact answer of this identity. So what I want us to do, just to double check everything, is to check all the original problem with the calculator, the answer I allowed you to stop at with the calculator, and this answer that I just finished with the calculator. So here we go. First thing we have is tangent of 255. That gives us this angle right here. Then I'm going to type in the angle that the answer that I allowed you to stop at, which is rad 3 plus 3 over 3 minus rad 3. And we see that we get the same answer. Then if I type in 2 plus rad 3, which is that last answer I get all of the same answers. Again, I would really like it if you could work towards the 2 rad 3 as the answer with the conjugate and stuff. But again, getting to where I allowed you to stop is a good point. So pause the video, take a look at example 3 if you have any questions. Again, make sure you write them down and you ask the next time you are in class. That's it for this video, and I will see you in the next one.